For number 2 here, we're instead of filling out a table, we're gonna do this a little bit more analytically. We have r equals 1 plus 2 cosine theta. First of all, we want to figure out for which values of theta is r equal to 0. Okay, r equals 0 is very important for polar graphs because that's where you hit the origin. Okay, so r equals 0, that would mean that 1 plus 2 cosine theta equals 0. If you subtract 1 from both sides, you'd get 2 cosine theta equals negative 1. If you divide both sides by 2, you'd see that cosine theta equals negative 1/2. And this is where you really need to look at your unit circle. You need to look, the unit circle. I'll just draw one on here, but you should have a filled out one maybe that you're looking at. Cosine theta is always the first coordinate on the unit circle, so we'd be looking for where the horizontal coordinate is negative 1/2. There's going to be 2 points like that, and the theta values are, one of them is 2 pi over 3, the other one's going to be 4 pi over 3 down here. Right, so those are the theta values. Those are the solutions to that equation between 0 and 2 pi, which are really, those are the ones that we're interested in. Okay. So those are the two theta values where r is 0. That means that for other theta values, r is either positive or negative. So to figure out which one is which, we could make a little number line here. Let's just put 0 and 2 pi at the extremes because we know those are the extremes for theta. And then 2 pi over 3 would be somewhere like here. 4 pi over 3 would be somewhere maybe here on the number line. We know that at these 2 points r is 0, so we've got 3 intervals here where r is either positive or negative. We just have to test them out. If you were to plug in, and you can test it out with a calculator or just thinking about maybe the unit circle. If you plugged in the theta value between 0 and 2 pi over 3, whoops, that would be like maybe somewhere here on the unit circle. Especially if you plugged in something like here, cosine theta would be positive, so that means the whole thing would be positive. If you plugged in something in between 2 pi over 3 and 4 pi over 3, like pi, for example, well, cosine of pi is negative 1, so this would be a negative 2. 1 plus negative 2 is negative 1. And really, yeah, r is going to be negative for all of those theta values between 2 pi over 3 and 4 pi over 3. And then if you move on bigger than 4 pi over 3, then then you'd be plugging in a theta value like down here on the unit circle, and especially like if you plugged it in right here, you'd have cosine theta to be positive. Again, r would be positive. Okay, so yeah, to answer the questions here, for which values of theta is r positive, from 0 to 2 pi over 3, and then also from 4 pi over 3 to 2 pi. That's where r is positive. R is negative between 2 pi over 3 and 4 pi over 3. Okay, it's important to understand that because when you do graph this function, right? When you do graph r equals 1 plus 2 cosine theta. Okay, first of all, I am going to change my window a little bit. I'm going to make x and y go from negative 3 to 3, just because I see that's the biggest that r could possibly be, is 3. So now I'm guaranteed to see the whole thing. Here's what the graph looks like. It's this strange graph that kind of loops on itself. And let's talk a little bit about what's going on with this graph here. This graph starts right here where theta is 0. Right, this is where theta equals 0. And then theta is positive, or theta increases, r is positive, 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 R is even positive here in the second quadrant for a little bit until you hit the origin, and then all of a sudden R is negative. R is negative, all in there. See, these are all theta values between 2 pi over 3 and 4 pi over 3. Normally those would be over here. Normally those would be in the second and third quadrants, but since R is negative for those values, it's kind of like you look in those directions but then go backwards, so you're actually flipped over here. This is a portion of the graph where R is negative. So you hit the origin, you got negative R's, you hit the origin again, and then all of a sudden now R is back to being positive. So like when theta is in the fourth quadrant, the graph is actually in the fourth quadrant. Okay, so really, when you're talking about this graph, there's really kind of three separate portions to this graph, and it's kind of instructive to play around with the window to understand those three different portions. If I only look at this first portion from 0 to say 2 pi over 3, notice it only gives me the top half of that outer loop. It only gives me this first red portion. Then if I change, if I go from 2 pi over 3 to 4 pi over 3, I get just the blue portion. I get that inner loop. That's like the second branch of this graph. And then if I go from 4 pi over 3 to 2 pi, I'll get the rest of it. I'll get this bottom half of the outer loop. Okay, it's important to realize that because some of the homework problems you're going to be asked for things about the outer loop or the inner loop of these types of graphs, and you need to know the theta values that actually gives you the portion of the graph that you actually want to deal with.